artificial sun? Why did China build an artificial star? It's only natural, given that the warm ball of light and heat high in the sky powers life on Earth by producing the equivalent of 1 trillion nuclear bombs each second, enough to power human civilization for 500,000 years per second. So, why has China decided to construct their own man-made sun? Nuclear power plants provide electricity for over 24 countries by converting water into steam that drives turbines. Nuclear efficiency is a process that breaks a heavy uranium atom into smaller atoms. There has to be a better approach than atomic fusion, which produces horrible things that are harmful for tens of thousands of years and radioactive for hundreds of thousands. The why isn't obvious, but nuclear fusion is the logical next step. Let's take fossil fuels as an example. The decomposed ancient plant and animal materials that are stored underground as fossil fuels provide the storage component. It's the same concept as a battery's electrical potential. Greenhouse gases from fossil fuels and radioactive waste from nuclear efficiency. These two methods have the best outputs, but are the worst for the environment. Once the sun is the key, the original producer of all energy transferred via sunshine and then stored on Earth by using neutron-heavy isotopes of hydrogen such as deuterium and tritium. China's fusion reactor, affectionately known as the artificial sun, was just recently successfully powered up for the first time. The world's largest and most advanced device for experimental nuclear fusion research is the HL-2M Takafake reactor. A massive magnetic field was used to fuse and hold the hot plasma while sending temperatures of up to 270 million degrees Fahrenheit. Not only could they fit a tiny sun within, they could hypothetically create a sun with a core 10 times as hot as ours. This plasma is an electrically conducting ionized gas. They need to be heated to 170 million degrees Fahrenheit, where they enter the higher plasma state and lose their electrons. The sun achieves this due to its large mass and huge gravity, compressing the core mass here on Earth. We use microwaves, lasers, and ion particles to achieve the same thing. Next up is pressure. On the other hand, the same nuclear fusion reaction that occurs on a vast scale in the sun can be replicated. Naturally, positively charged protons in each atomic nucleus repel each other in the same manner that the north poles of a magnet must be forced together in order for the phenomena to occur. To get the hydrogen isotopes excited enough to overcome their electrical repulsion, it takes a lot of heat and pressure. The sun, as previously indicated, is huge, and its gravitational pull is sufficient to squeeze the hydrogen together to create helium. This is the difficult phase since we need to contain and compress the plasma in order for it to serve as the conductor. The Chinese want to employ this out-of-this-world technology in conjunction with the International Thermonuclear Experimental Reactor, which is now under construction in France to start the fusion reaction. It will become the new king of nuclear fusion, the largest and most powerful in the world, when it is completed in 2025. This reactor currently uses a deuterium to triple neutron tritium fusion reaction. However, deuterium to deuterium fusion demands far greater temperatures and is considered the holy grail of nuclear fusion. There's a simple reason for this. It's simple to put together. Deuterium is easily extracted from salt water, while tritium can only be created from lithium, which is famously difficult. The ultimate goal is to generate sustainable energy from a controlled fusion reaction using only salt water. A pure deuterium fuel source has the extra benefit of increasing energy. Deuterium makes up about 1 out of every 5,000 hydrogen atoms in seawater. 1 gallon of seawater could theoretically produce the same amount of energy as 300 gallons of gasoline. It combines the best of both spaces: electricity generation without causing major environmental damage. So, this was today's video. Please like, share, comment, and subscribe to our channel. See you in the next video.